So I've got an integration by parts example here for us to look at, and just warning everyone up front, it's going to take some work to get to the final result. But if you've made it this far in studying integration by parts, it's a great example of the power of the technique. Even in a situation like this, where due to that additional n parameter, it can't give us a final solution. It can still show us how to simplify the expression in a way that will eventually lead to that final closed form answer that we really want from this kind of problem. So first, I need to get this into a form where we can use integration by parts, and it's really not there yet. My only option here would be to let u equal cosine n of x. Couldn't let dv equal that, since the whole point of the question is how do you integrate this? And I don't think that would be a really beneficial approach. So what I'm going to do instead is I'm going to take that cosine to the n of x, and I'm going to split it up. Right? I'm going to turn it into cosine of x times the cosine to the n minus 1 of x. Now I've turned this into something with two parts that kind of makes it look more like an integration by parts situation. Right? So I'm going to let u equal that cosine n minus 1 part, the part that I really don't want to try to integrate. And then dv will be the cosine of x dx. Right, so differentiating the du part using the chain rule, we get du equals negative quantity n minus 1 cosine of the n minus 2 times the derivative of the inside part of the cosine. That's where the minus comes from, and the sine of x. And then we need to integrate the dv here, and that's simple enough. The integral of the cosine is just the sine. Right, so now we're going to go to the formula. Right, the formula says the integral is equal to u dv minus the integral of b du. The du part is mostly this piece here, and of course, it's also that dx at the end. All right, so now I'm just going to simplify some stuff. Got a lot of minus signs floating around in here, right? All I'm going to do is simplify those minus signs and combine the two sine of x's under the integral, inside the integral. Okay, so now what do we do? I reduced the exponent on that cosine, which was nice, but I still have that sine squared floating around in there. Right, so my next step is going to say, well, I'd really like this integral to be just in terms of cosines. So I'm going to replace that sine squared x with 1 minus cosine squared. Right, now for my next step, I'm going to take this cosine n minus 2, and I'm going to distribute it into the parentheses. Right, cosine n minus 2 of x times 1, that just gives me this cosine n minus 2 here. And remember, when multiplying exponents, you add them. N minus 2 plus 2 is just n. That's where this piece comes from. Right, now I'm out of room, right? So let's new slide here. And I'm going to start off with the last line from the previous slide. Right? That's just where we left off. So the next thing I'm going to do here is I'm going to take that integral and I'm going to split it in two. Right? So I've got n minus 1 times cosine of n minus 2x. And I've got minus n minus 1 integral cosine n of x. Now, what I want you to notice here is I have the integral cosine nx on both sides of the equation. Right? So my next step, this is kind of the cool step, I'm going to add n minus 1 cosine, integral cosine to the n x to both sides. It's going to cancel over here. Right? It's going to go away. Then over here, I have 1 times the integral plus n minus 1 times the integral. That's going to leave me with just n times the integral cosine to the n of x. On the right side, you see how I canceled out that second integral. And now we're right where we want to be to get the final answer. All this, the right-hand side looks almost exactly like what the formula said I should expect. The left-hand side, I've just got that n getting in the way. If we divide both sides by n, we end up with exactly the expression we were looking for. So there was a lot going on there. This is the kind of thing where you might want to go back and watch it again, right now that you've got the big picture, really kind of focus in on the details. There were two really key steps to this, I think. The first one was the very first step where I split the integrand up into two pieces. That was the step that really put this into a form where integration by parts was a practical choice to approach it. And the second one was near the end where I added that integral to both sides, right? That I don't say it's necessarily a common technique, but it comes up enough that it's definitely a tool that you should be aware of, as something to have in your toolbox. So if you'd like to get the full context, you can click on the link here to see the corresponding integration by parts lecture. And if you like this example or found it helpful, please go ahead and click on the like button below.